looking at 10.5, which says I can evaluate trigonometric angles by finding the reference angle and applying the unit circle. So I'm trying to look a lot at all our special right angles, right? The sine and the cosine of 30, 45, 60, pi over 6, all of them, right? Those have to be memorized, and this is why we can use those to find our trig values of any really special angle, not in the first quadrant. Okay? So, our steps for finding trigonometric functions. Find the reference angle, which we call theta prime, and then evaluate the trig function. So if it's sine, right, if you find your reference angle will be 30, find the sine of 30. And then your last step is just to determine the sign of the trigonometric function from the quadrant. And what that really means is, I think a lot of us saw this the other day when we were doing the Pythagorean identities, right? If sine is this, what's cosine in like the second quadrant or the third quadrant? We started really noticing where things were positive or negative and all of that. So there are rules we follow, and it's ASTC, and a nice thing to remember is all students take calculus. Okay, so it's kind of our mnemonic device, is that what it's called, to remember this. And really what that stands for is, in the first quadrant, all trig values are positive. Okay, so in the first quadrant, all trig values are positive. In the second quadrant, just sine is positive, cosine and tangent are negative. And again, you can see that with cosine is definitely negative because I'm going this way, right? Cosine is my x value, so my x value is going to the left. In the third quadrant, tangent is positive. Again, that makes sense for cosine is negative, and sine, which is my y, is negative. And then C, just cosine is positive here, right? Okay, that makes sense. Cosine is positive, sine is negative in that fourth quadrant. So all sine, tangent, cosine, or all students take calculus. So let's look at an example. For number 1, our first step was to find the reference angle. So we're always going to start by drawing. So I have 210 degrees, so that's 0, 90, 180, 270. So it's going to go here. So it's in quadrant 3. Right? Then, I want to find my reference angle. So my reference angle is going to be here. That's theta prime. So theta prime equals 210 minus 180. So theta prime equals 30 degrees. Our next step is to find the sine and cosine of 30. Right? Sine of 30 degrees is 1/2. Cosine of 30 degrees is square root 3/2. That's coming straight from our unit circle. So if you need to look back at your unit circle for now, that's good. But again, that unit circle will have to be memorized. Again, one way I think about it, which we've taught, our y value is going to be smaller than our x value in that 30-degree angle because it's closer to the x-axis. Right? We kind of talked about that when we were filling out our unit circle. Okay. And then our last thing is to think about the STC part, which sign it's going to have. So sine of 210. Well, in the third quadrant, my sign is negative because only tangent is positive. Again, cosine is negative. So sine of 210 equals negative 1/2. Cosine of 210 equals negative square root 3 over 2. And that's it. Let's look at 120. So we have 0 to 90 to 180. Right? So 120 is going to be about here. It's a little closer to 90. That's theta. So here's theta prime. So how far away are we from 180? So theta prime equals 180 minus 120. We always do the bigger minus the smaller. So bigger minus smaller, which is 60 degrees. And this is in quadrant 2, right? So then find the sine of this and cosine of that. Sine of 60. Well, the sine of 60 using our unit circle is square root 3 over 2. The cosine of 60 using our unit circle is 1/2. Right. Then we have to think about the sine. All students take calculus, right? So this is in the second quadrant, so sine is positive. So the sine of 120 degrees stays as square root 3 over 2. The cosine of 120 degrees is negative 1/2. All right, looking at our next example, 300. So we have 0, 90, 180, 270, 360, right? So it's going to be here, loop around. This is our reference angle for 330. So we're close to 360, so for my reference angle, it's going to be 360 minus 330 degrees. This is another 30-degree angle, which is in quadrant 4. So the sine of 30 is 1/2. The cosine of 30 is square root 3 over 2. Again, it's the same as what we just did up in example 1. Right, again, and this is coming from your unit circle. If you look at your unit circle, you can see, okay, sine of 30 is 1/2, right? Your y value, your x value. And then, so that means when we look at our all students take calculus part, sine of 300, well, in this quadrant, cosine is positive only, so sine has to be negative. And cosine of 300 degrees, well, cosine is positive, so it stays as square root 3 over 2. Alright, last example for degrees before we look at radians. 180 degrees. 0, 90, 180. So this one falls right on a line, right? So when it falls right on a line, your process is a little different. Again, remember, your y is your sine of theta, and your x is your cosine of theta. Right? We know this is the unit circle. Right? So this distance is 1, and it's -1 because it's going left. So my x value here is -1, my y value is 0. So the sine of 180 degrees is 0, and the cosine of 180 degrees is -1. Okay, so those, if it lands right on one of your axes, just know like it's always 1 away. Okay, so you can use that. There's usually some form of 1 and 0 in there. Alright, go ahead and turn to the next page. We have 4 more problems which we're going to look at with radians instead of degrees. But still all the same process. So we have to draw this 2 pi over 3. So again, I'm going to cut it into thirds. I want orange. So I want to cut the top half into thirds, bottom half into thirds. And then I'm going 2 of them. 1, 2. And that's my theta. Again, my y-axis is not part of those cuts in this one. So finding my reference angle, that's theta prime. Again, with these ones, if I'm going from here to here, it's in thirds, and I'm only going one of them. You're really always only going one of them for when we kind of have these radians. They're a lot easier, I think, for that reference angle. So theta prime is pi over 3. It's not letting me make it bigger. So then we have to find the sine and cosine of our reference angle. So the sine of pi over 3. And if you use your unit circle, it's square root 3 over 2. And the cosine of pi over 3 is 1/2. Then, all students take calculus. We're in this one, we're in quadrant 2, so sine is positive. So sine of 2 pi over 3 is positive square root 3 over 2. Cosine of 2 pi over 3, okay, well, sine is positive, so cosine is negative, so negative 1/2. And that's it. Number 6, drawing our lovely picture. 7 pi over 4. So I'm going to cut this top half into fourths, so cut once. Alright, so I have 1, 2, 3, 4. 1, 2, 3, 4. Great. And then I want to go 7 of them. 4, 5, 6, 7. So that's theta. So then the rest, right, this is closest to here. Again, it's the x-axis that it's closest to. It has nothing to do with your y-axis. So that's theta prime. So then theta prime equals pi over 4. It's one section out of 4, right? Then using our unit circle, sine of pi over 4 is square root 2 over 2. Cosine of pi over 4 is square root 2 over 2. Now we have to think about our sines. All students take calculus. We're in this one, so cosine is positive. So sine of 7 pi over 4 is negative square root 2 over 2. Cosine of 7 pi over 4 is positive square root 2 over 2. Right? Cosine's positive, so sine is negative. Alright, sometimes you'll get an easy question like 7. It's a lot less work because when I draw it, we can still draw our lovely picture. But, alright, here's this, cutting it into sixths, this piece into sixths, right? So I have 1, 2, 3, 4, 5, 6 sections here. 1, 2, 3, 4, 5, 6 sections there. Okay, going 1 pi out of 6 pieces is just here in the first quadrant. This is theta. It's also theta prime. Right, in our first quadrant, our angle is equal to our reference angle. So all I have to do is what's sine of pi over 6? Well, that's 1/2. Sorry, I forgot to draw this other part. Cosine of pi over 6, right, again, this is coming straight from our unit circle, is square root 3 over 2. And I don't have to do the other pieces of it because the angle is the reference angle. I don't have to figure out the signs again. All right, number 8, our last question. Three pi over 2. So I'm going to cut this half into 2 sections. Nice and easy. Same thing on the bottom. So it's just your axes. And I'm going to go 3 of them. So 1, 2, 3. Again, this is one that's right on our unit circle. So I'm just going to figure out the point. All right, if this is our unit circle, then we didn't go left or right. So my x value would just be 0. Sorry, 0, comma. And my y value is -1. All right, because then we went down 1. So for ones that fall on the axes, that's fine. We just write down the point. And again, sine is y, cosine equals x. Right? So the sine of 3 pi over 2 is our y value. The cosine of 3 pi over 2 is our x value. All right, and that is it.